11.2, converting between rectangular coordinates and polar coordinates. So we've talked about rectangular coordinates for many years, and we've recently talked about polar coordinates. Well, on a polar coordinate, you have an r and you have a theta. Well, that's the ordered pair, r comma theta. And in a rectangular coordinate, you have x comma y. Well, to convert between the two, we have to use a little bit of trick. If we know theta, we can use cosine of theta, and we can find cosine of theta would be adjacent over hypotenuse, so which is x over r. And so if we know r and we know theta, we can get the x value. And sine of theta is opposite over hypotenuse, which would be y over r. And so if we multiply both sides by r, we can get y equals r times the sine of theta. If we're in rectangular and want to go to polar, tangent would give you, tangent of theta is opposite over adjacent, so y over x, and then the inverse tangent would give us the angle. And the Pythagorean theorem, x squared plus y squared equals r squared, so this length would be the square root of x squared plus y squared. It's the hypotenuse. So that is the main way to convert between the two, and it'll make more sense when you see this when you actually start practicing it. But main thing to remember, there's more than one possible point. So we have to look for other values that could be the same. Like sometimes you can have a negative radius, or sometimes it could be in another rotation around the circle, or a different quadrant where those values are still positive. So step one, I make a little sketch. Let's see. We've got the rectangular coordinates are given, and we want to get the polar coordinate. So positive square root of 3 means positive on the x and negative on the y. So it's in the fourth quadrant. So when I do my polar coordinate, I need to make sure I pick a value that's in the fourth quadrant. So here's the ordered pair, this square root of 3 comma negative 3. Well, to convert from rectangular to polar, we're using this one. So theta is inverse tangent. So theta is inverse tangent of y over x. Well, y was negative 3, x was square root of 3. Well, that's actually a value on the unit circle. We just do a little rationalizing here. That'd be negative 3 over square root of 3. We don't leave a square root in the bottom, so if I multiply by square root of 3 over square root of 3, you get negative 3 square root of 3 divided by the square root of 3. Oops, sorry, divided by 3. That's my mistake. That should just be a 3 on the denominator. Divided by 3. So I want to know where tangent is equal to negative square root of 3. So if we pull up our unit circle, so here's our unit circle. So we're looking for where tangent has a negative square root of 3. Here's positive square root of 3. Here's a negative square root of 3. And also, here's square root of 3. So that would be either 300 degrees or 5 pi over 3. So let's go back to, I lost my page. Oops, here we go. So theta could be 300 degrees, could be 5 pi over 3, could be another rotation around the circle, so you could add 2 pi to that. And then r, let's talk about r. R is this length, and we said r was the formula. What's Pythagorean theorem? R is the square root of x squared plus y squared. So r is the square root, it's the hypotenuse of square root of 3 squared plus 3 squared, which is 3 plus 9, which is square root of 12. And 12 is 4 times 3, and I know the square root of 4, so that's 2 square root of 3. So r is 2 square root of 3, and theta, depending on whether we're in degrees or radians, could be 300 or 5 pi over 3. However, so let's list our ordered pair. So we could say it was 2 square root of 3 comma 5 pi over 3, 2 square root of 3 comma 300 degrees, and then if you recall on polar coordinates, if we had a point here, well, if we had a negative radius, if we had put this point in this quadrant, and had a negative radius, that would go 180 degrees. So it also could be, let's go back to that. It could also be, we want to square root of 3 would match this one. So it could also be these two values with a negative radius. So negative radius, so negative 2 squared of 3, comma, 120 degrees. And also negative 2 squared of 3, comma, not degrees, radians. And the other radians, oops, I went the wrong way again. The radians was 2 pi over 3. So 2 pi over 3. And these are all possibilities. Yours is multiple choice, so you have to find the one that is in the correct form. And that's the main way you're going to do these. So let's try another one. So let me clear this off so I can go to actually do number 2. So number 2 says we're given a rectangular coordinate again, and the point is 0, 9. So over 0, up 9. So we're on the y-axis up here. So let's do r first. R is the square root of x squared plus y squared, which is 0 squared plus 9 squared, which is just going to be 9. So r is 9, because that's 0 plus 81, square root of 81 is 9. Theta is, if we look back at the top, theta is inverse tangent of y over x. So theta is equal to the inverse tangent of y over, oh, I forgot to put inverse, y over 0. Well, we can't divide by 0. That's undefined. So we're looking for when tangent is undefined. Well, let's go to our unit circle. And we know it's up here. So tangent is undefined at 90 degrees. 90 degrees or pi over 2. So one answer to this problem would be, we know r is 9. And we know theta is the number of degrees or radians. So 90 degrees. Or pi over 2 radians. Then we also could have had a negative radius. If it was a negative radius, it would have been down here and then just translates 180 degrees. So these degrees, or these radians or degrees, but then radius would be negative. So 270 degrees. So it would be negative 9, 270 degrees. And negative 9, and the radians was 3 pi over 2. Well, let's try another one. On the next one, we're given the polar coordinates, and this time we want to find the rectangular coordinates. Well, to go from, we know r is 10, and we know theta is 7 pi over 4, so we're in radians on this one. So let's see. So x is, if we're going to polar, or from polar to rectangular, x is r times the cosine of theta. So we're doing 10 times the cosine of 7 pi over 4. So let's go look at our unit circle. Is 7 pi over 4 on our unit circle? And 7 pi over 4 is on our unit circle. Let me clear all these marks off. Ooh, no, didn't mean to do that one. So I'll have to undo to clear them all off and I'll do that later. So 7 pi over 4, and we want cosine. Cosine is square root of 2 over 2. So that is 10 times square root of 2 over 2, which is 5 square root of 2. Y is, if we look back at the top here, y is r times sine of theta. So 10 times the sine of 7 pi over 4. And if we go back to the unit circle, sine is just negative square root of 2 over 2. So 10 times negative square root of 2 over 2, which is going to be a negative 5 square root of 2. So the ordered pair is 5 square root of 2, sorry. 5 square root of 2, no comma, comma, negative 5 square root of 2. And now let's do, I forgot to do a little sketch on this one. Radius of 10, 7 pi over 4 was in this quadrant. And if we look at this, we go to the right 5 and down 5. So yeah, 5 square root of 2 and down 5 square root of 2. So that one matches up. Let's try that again, but this time we're given the answer in degrees. So we have the polar coordinate. Clear everything off here. We have the polar coordinate, -8. Let's sketch where this one is. 150 degrees will be right here. So -8, though, means it's going to be down here, since it's a negative radius. So we're in the fourth quadrant. So let's look at what we're going to come up with here. X is r times the cosine of theta, which in this case would be -8 times the cosine of 150 degrees. So we go back to the unit circle, and let me see if I can clear some of these off of there. I was going to do that before I had it paused, but never paused. Okay. So 150 degrees is right here, and cosine is -√3/2. So that is equal to, I'm doing bad about my equals, equal to -8 times √3/2. Was it negative? I already forgot. -√3/2. So -√3/2, which 2 makes that 4. Negative times a negative is positive 4√3. Y is equal to r times the sine of theta, which in this case would be -8 times the sine of 150 degrees. If we go back to our unit circle, sine is 1/2. So it is -8 times 1/2, which is -4. So the ordered pair is 4√3, -4. And 4√3 is a positive, and -4, yep, so it matches it. We kind of spot check to make sure we're doing it right. Well, let's try another one. We're given the polar coordinate of -1, so -1, -180. Let's see, that's the polar coordinate. So that is a radius, and this -180 degrees is here. But a negative radius shoots it across the origin, so it's over here. So x is going to be equal to -1 times, so r times the cosine of theta, which is -1 cosine of -180, cosine of 180, well, positive 180 and negative 180 is the same thing, because whether you go this way or this way, 180 degrees, cosine is -1. So -1 times -1, which is 1. Sorry. Y is r times the sine of 180, or -180 in this case, sorry. And sine of 180 is 0, or -180. So that's -1 times 0, which is 0. And so the ordered pair is 1, 0. And if you look, that would be the ordered pair 1, 0. So it's a good way to check to make sure you're doing it right. So for the next one, we have the rectangular coordinate given, and we want to find the polar coordinates. So we have x and we have y. So let's kind of sketch where this one would be. 2.8 is the x, and -72 is, so it's in the fourth quadrant. And this one we're going to round to 2 decimal places. So let's look at how to convert from rectangular to polar again. Rectangular, we have to find r and we have to find theta. So r is going to be the square root of x squared plus y squared. So r is equal to the square root of 2.8 squared plus -72 squared. And let's use a calculator for that one. And square root of 2.8 squared plus 72 squared, we're going to get 72.05. So equals 72.05 if I round to 2 decimal places. And theta is in degrees, they told us. So theta, we're going to need degrees. So theta is the inverse tangent of y over x. So the inverse tangent of -72 divided by 2.8. So let's use our calculator. And I notice I'm in radians, so I'm going to hit Document and Settings, and Document Settings, and I'm going to change that to degrees. And now I need trig inverse tangent of -72 divided by 2.8. -72 divided by 2.8. And you get negative 87.77 equals negative 87.77. And so if we look at R was a 72, which is a positive radius, and then negative y value, negative theta, and that'd be, that one's equivalent. Another version of that answer could be, well, they could add 360 degrees to that, or they could have gone over here and done the one in the second quadrant, made the radius negative, and done that one. But I think we're going to just stick with that ordered pair that we're given, 72.05, comma, negative 87.77. Like I said, an equivalent version would be make the radius negative and find this angle, which would be actually, we can talk about that. This angle is 180 degrees, and we need to go back up. So it take, if you take the 87.77 and subtract 180 from that, that would give you an equivalent version. And that's all on the front. Let's go to the next problem. So for the next one, we're given a rectangular coordinate, which is 4, 3.2. So to the right 4 and up 3.2. It's in the first quadrant. And we want to find the polar coordinate to 2 decimal places with theta and radians this time. So I need to get from polar to rectangular, so we need to find out what r is. And r is going to be the square root of x squared plus y squared. So 4 squared plus 3.2 squared, and take the square root of that. So square root of 4 squared plus 3.2 squared. Oh, got some extra digits in there that the pen did. Ooh, 4.2 squared plus 3.2 squared gives us 5.12. So r is 5.12. And to get theta, well, theta is the inverse tangent of y over x. So that would be 3.2 divided by 4. And this time, though, I need to be in, it says in radians. So in radians, I'm going to go document and switch this back to settings, document settings, and switch that back to radians. And I need inverse tangent, so trig tangent of, what was it? It was 3.2 divided by 4. So 3.2 divided by 4, and you get 0.67. So 0.67 radians. And so if we had a positive radius and a positive 0.67, that would be in the first quadrant. An equivalent version, you could add 2 pi to this or subtract 2 pi from that. And another way to do that one is if we were in this quadrant, which would be pi plus this 0.67, and had a negative radius. So a negative 5.12, and then, sorry about that. 0.67 plus pi would get us 0.6. Well, the pi and then plus 0.67 more would get us in that same version. So whatever that decimal number would be. Okay, last one. We're given polar coordinates, and we want to get the rectangular coordinates. And 210 is actually on our unit circle, and I forgot I had a nice pretty unit circle that I could have been using instead of the handwritten one that I was using before, but it works. So 20 degrees, or 20 is the radius, and 210 degrees is going to be in the third quadrant. And to get the rectangular coordinates, x is r times the cosine of theta. So the r is 20 times the cosine of 210. And 210 is on our unit circle. So cosine of 210 is negative square root of 3 over 2. So that is 20 times negative square root of 3 over 2. And if I find out what that value is, 20 times negative square root of 3 divided by 2. Ooh. And you get negative 17.32. Did it say 2 decimals? Yes. So negative 17.32 is our x value. Y is r times the sine of theta, which is going to be 20 times the sine of 210. And if we go look, sine of 210 is negative 1/2. So 20 times negative 1/2, which is just negative 10. So the ordered pair is negative 17.32 comma negative 10. And a negative x and a negative y, negative x, negative y, yep, it's in the third quadrant, so it's a good way to double check ourselves. And that is the main stuff you need to know. Don't forget, I did it by using the unit circle, but if you could also just know these values to convert from degrees to radians or radians to degrees. Good luck to you.